All right, today we're doing section 9.3. We are going to find the surface area of pyramids and cones. So much like when we did volume, we started with prisms and cylinders. Then we did pyramids and cones. We did surface area of prisms and cylinders. Now we'll do pyramids and cones. All right, let's go ahead and review a little bit. For now, I think we'll just start with doing warm-ups 1 and 3. We did get some practice of this in on our worksheet. We did not, however, do the same type of prism that we have in number 1. What type of prism is number 1? A rectangular prism. So you kind of have to choose which rectangle represents your base. You want it to be the top or bottom, front or back, side or side. Top and bottom. I like that for rectangular prisms. So remember we talked about drawing out your base and labeling it, because that might help you when it comes to our surface area formula. To find surface area of a prism, we've repeated the formula a couple times already today. 2 times capital B plus P times H. What does capital B represent? Area of the base. So if our base is a rectangle, how do we find its area? How do we find the area of a rectangle? Base times height. So capital B could be found by taking what times what? 3 times what? 2. So our capital B in this problem equals 6. Okay, we can plug that in. Next, we move down in the formula. We're trying to find the perimeter. What's the perimeter of our base? It would be 10 to find our perimeter. We add up all the sides. I've only got 2 of them labeled, but I know the other 2 are the same. So 2 plus 3 plus 2 plus 3 would give me 10. Times, now we have another H. This time it's the height of the entire prism. What is it? 6. The distance between our rectangular bases. All right, now we just have to do a little multiplying and adding. 2 times 6 is 12. 10 times 6. When we add them together, 72, my units. Inches squared. Questions about warm-up 1? Number 3, what kind of solid do we have? A cylinder. Again, we've talked about the surface area. 2 pi r squared plus 2 pi r h. Personally, I think surface area of a cylinder is easier because we don't have other things to calculate. We can just go ahead and start plugging in our values. What am I plugging in for R? 7. And what am I plugging in for H? 10, the height of the cylinder. Now we've just got to do some multiplying and then a little bit of adding. 7 squared is 49 times 2. 49 times 2 is 98. Plus, we've got 2 times 7 times 10. 140. Okay, we've got to add our pies together. 98 plus 140. 238 pi, and then they wanted it rounded to the nearest whole number, so we'll go ahead and multiply and then round. $748. My units? Centimeters squared. Good. All right, questions about our surface area that we did yesterday?
No.
All right, let's jump into our definitions for today. All right. For our definitions today, a pyramid has one base. That's nothing new to us. The lateral edges are not parallel, but they do meet at a single vertex. Lateral faces will always be triangles. And we name a pyramid by its base. A regular pyramid has a regular polygon as its base, and also congruent isosceles triangle lateral faces. The height of a pyramid is the perpendicular distance between the vertex and the base. That can be kind of hard to see sometimes. But what it means is it goes through the very middle of the pyramid. So it starts up at that top point and drops down the very middle of the pyramid and makes a right angle with that flat base at the bottom. The slant height is the height of any lateral face. So like if you were to slide down from the vertex along one of the faces, that's called the lateral height. Sorry, the slant height, not the lateral height. The slant height, it's on a lateral face, and they denote it with a cursive L. That's what that is in parentheses right there, a little cursive L. All right, so on this first example, very bottom of the front side of your notes, all they want us to do is find the slant height, which they denoted with that cursive L. So the slant height goes down the side of one of the lateral faces. Okay. What we end up having to do is create our own right triangle that goes inside of the pyramid. So I'm going to use the actual height that dropped down because it makes a right angle. The slant height, which goes down the side of that face, and then connect it in to the middle of the pyramid to make myself a right triangle. So I would, again, recommend kind of drawing that out separate so that way you don't get too confused with the diagram. Now this straight side that went down, how long was that? 15. They'd labeled that for us and went straight down the middle of my pyramid. The slant height that we're trying to find, which is the hypotenuse, we don't know that we'll go ahead and use that cursive lowercase l, since that's what they used for it. The tricky part can be knowing how long this bottom leg is. Anybody have any ideas? It would be 9. So this cuts halfway into the base of our pyramid. So if a base side is 18, we're cutting through half of it. We're going to use a 9. We have questions about how we set it up or why we set it up this way. Now, what do you think we're going to have to use to find the slant height? Pythagorean theorem. A squared plus b squared equals c squared. What should I plug in for a? 9 squared plus 15 squared equals L squared. What is 9 squared? 81 plus 15 squared. 225 equals L squared. When I add 81 and 225, do we agree with 306? And then what are we going to have to do to get L alone? Square root. So if we're rounding it, let's round to the nearest tenth. What do we get? Sounds like you're, oh, okay. I thought you were saying 77. I was like, that's too big. No, it's okay. 17.5. My units would be feet. Should it be squared? No, we're finding one dimension. We're not finding area. So it's just feet. Now, I think we could have simplified that radical without getting a decimal approximation, but I'll be fine with decimal approximations for now. Do we understand how we can find the slant height, or L, if we need to? It might be necessary to calculate that on some of our problems. Okay. On to the back. We have our surface area of a pyramid. The surface area of a pyramid is capital B, which still stands for what? Area of a base. So if you still need to write that as a reminder, you can. Why do you think it's just big B and not 2 times big B? And a pyramid only has? No. Pyramid has how many bases? 1. And a prism has how many bases? 2. So for a prism, we had to multiply this by 2. But for a pyramid, there's only 1 base. So we only have capital B, not times 2. Yeah. Plus 1/2 times capital P times lowercase l. I personally would write this as a cursive L. What do you think capital P stands for? The perimeter of, not of the pyramid. That doesn't really make sense. The base, perimeter of the base. And that lowercase l represents what? No. What kind of height? Slant height. We just talked about it. Okay, so then what they circled, the 1/2 PL, that is how we would calculate just the lateral area. Just the surface area of the faces, not of the base. All right, on example 1. So I'll write the formula up at the top, even though you should already have it written on your page. Find the lateral area and the surface area of the regular square pyramid. So the first thing they want is lateral area. So that's just the part where we have to take 1/2 times P times L. What shape does my base have? A square. They told me it was a square. So what is the perimeter of that base? 8. All the sides are 2. Add them all up, we get 8. What number that they gave us is our lowercase l? 3. It's along the side of one of our lateral faces. Is that 3? So that's our lowercase l. What is half of 8?
4
Times 3?
12.
So our lateral area is 12. What's my units? Meters squared. Now when we go to find surface area, much like yesterday, once we have our lateral area, we just have to plug that in. So my surface area is going to be capital B plus what? Do I need to write down 1/2 times PL again? No. What number could I put here? 12. We already found 1/2 times PL. So now the only thing I really need to know now is capital B. Capital B stands for what? Area of the base. So how do I find the area of my base? No. Side squared. The area of a square is side squared, or if you want to treat it like a rectangle, you could take base times height. Either way, what do we get for capital B?
8.
No.
6. 4.
What is 2 times 2?
4.
4. What's my surface area? 16 meters squared. On examples 2 and 3, they are asking if we have a regular pyramid and also for us to find the surface area. So on number 2, is this a regular pyramid?
Yes.
How do we know?
It's a square base.
Base is a regular polygon, so yes, it would be a regular pyramid. What about on number 3?
Yes.
Yes, again, its base is a
Square.
square, so it's a regular pyramid. Let's move on to finding the surface area. Capital B plus 1/2 PL. What is capital B for number 2? 36. Plus 1/2 times. What's the perimeter of my base? 24. Times my slant height? 12. So we have 36 plus, what's half of 24? 12 times 12 is 144. When we add those together, we get 180. My units? Centimeters squared. Next one. Same formula. What is capital B for number 3? 100 plus 1/2 times my P 40 times my slant height. Is my slant height 8?
No, it's X.
They did not give it to us, so we are going to have to find it. So that's why we did an example similar to this before. So if I draw out this right triangle that cuts into my pyramid, we could label this side 8. The hypotenuse is my slant height. What would I label that bottom side? What is it? 5. It cuts halfway into our base of our pyramid. So to calculate that, what are we going to have to do? Pythagorean theorem. What's going in for A?
8.
What about B? C is L. 8 squared. 5 squared.
25.
Add them together to get L alone. Square root it. What do we get for L? 9.4. Sounds good. All right, we've got to take half of 40, 20, multiply it by 9.4. 188. Okay, last up. We add them together, we get 288, our units. Meters squared. For surface area of a cone, we've got pi r squared plus pi r L. Again, I would treat this like a cursive L. What do you think R still stands for? Radius. L is still our slant height.